Our solar system is hiding more secrets than we have yet solved. Scientists and astronomers are still baffled by at least 25 cosmic phenomena right in our own celestial neighborhood. You are about to explore the most perplexing enigmas, from a hexagon swirling at Saturn's pole to a strange signal from deep space that was never heard again. By the end, you will know the biggest unsolved puzzles that are redefining our understanding of the cosmos. What force is pulling entire galaxy clusters toward the edge of the known universe, and why does a distant star keep winking out in impossible ways? Which of these cosmic riddles do you find the most compelling? Spinning at Saturn's north pole is a perfect geometric storm. This is no ordinary hurricane. It is a colossal hexagon, a six-sided cloud pattern so vast it could swallow 4 Earths whole. Its discovery was a complete accident. The Voyager probes first glimpsed it in the 1980s, a strange, angular shape in the fuzzy data. Decades later, the Cassini spacecraft arrived for a longer look, confirming that this was not a fleeting illusion. The hexagon is a permanent, towering structure of clouds, a whirlwind locked in a precise geometric dance. Think of the most turbulent storm you can imagine, then picture it constrained within the sharp, unwavering edges of a hexagon. It defies every expectation of how weather, even on a gas giant, should behave. The theories scientists have proposed are as fascinating as the phenomenon itself. One leading idea points to atmospheric waves. Deep within Saturn's churning atmosphere, a complex interplay of jet streams, like rivers of wind moving at different speeds, could potentially create a standing wave pattern. Under the right conditions, this pattern might just snap into a hexagonal shape. It is a bit like how a musician can create a specific note by vibrating a column of air, but on a planetary, almost unimaginable scale. Yet this remains just a theory. Why is this shape so stable, enduring for decades without distorting? And why a hexagon? Why not a pentagon or an octagon? This feature is utterly unique in our solar system. A stark reminder that the rules of physics can paint pictures we are only just beginning to understand. That geometric perfection at Saturn is a puzzle written in clouds, but the next mystery arrived as a silent scream from the void. In the summer of 1977, a radio telescope at Ohio State University known as the Big Ear was engaged in its routine sweep of the sky, listening for anything out of the ordinary. On August 15th, a volunteer named Jerry Amon was reviewing the telescope's computer printout, a long scroll of paper filled with columns of letters and numbers that represented the faint hiss of cosmic radio noise. His eyes locked onto one particular sequence. The signal was so powerful that it maxed out the equipment scale. Amon, stunned, circled the alphanumeric code on the printout and wrote a single, emphatic word in the margin: "Wow." That one word would give the signal its immortal name. It was a narrowband radio burst precisely at the frequency of the hydrogen line, a wavelength many scientists speculated would be ideal for interstellar communication. It lasted for 72 seconds, the exact time it took for the Big Ear's fixed telescope to scan that single point in the sky, rising to a peak intensity and then fading away exactly as expected. It came from the direction of the constellation Sagittarius, a region devoid of any known stars or planets at that time. The search for a repeat began almost immediately. Astronomers pointed every available instrument toward that same patch of sky, listening again and again for decades. They heard nothing. The wow signal was a one-time event, a cosmic shout that was never repeated. The debate over its origin has raged ever since. Was it a message, a deliberate broadcast from an intelligence that briefly turned its transmitter in our direction? Or was it a bizarre, never-before-seen form of natural astrophysical event, a burst of energy so unique we have never witnessed its like again? The most prosaic explanation, that it was some form of human-made interference, seems unlikely. Military and civilian transmissions were ruled out, and no satellite was in the right position. it remains the most tantalizing and frustrating candidate for a signal not of this Earth, a ghost in the cosmic machine that appeared for just over a minute and then vanished forever, leaving behind a single word that captures our enduring sense of wonder. That solitary signal is a mystery of something we might have heard, but the next enigma is a matter of something we cannot see, a motion on the grandest scale imaginable. Entire clusters of galaxies, each a sprawling metropolis of billions of stars, are being pulled in the same direction. This phenomenon is called the dark flow. It was discovered not by looking at the galaxies themselves, but by studying the oldest light in the universe, the cosmic microwave background. This faint afterglow is the leftover heat from the Big Bang, a baby picture of the cosmos. Scientists used it as a cosmic frame of reference. By carefully measuring how this ancient light was distorted as it passed through moving galaxy clusters, they detected a startling drift. It was as if a vast, unseen river was carrying these clusters at staggering speeds toward a single point on the cosmic map. The force required for this coordinated movement is almost incomprehensible. According to our standard model of cosmology, the universe is mostly uniform on such large scales. Matter and energy should be distributed evenly enough that there is no preferred direction for everything to flow. The gravitational tug from known structures should cancel out, so what could possibly be exerting such a profound pull? The most radical hypothesis points to something beyond the edge of our observable universe. We can only see so far. A bubble defined by the distance light has had time to travel since the beginning. The dark flow suggests that outside this bubble there exists a colossal, uneven distribution of matter. Perhaps it is a region of space so densely packed with galaxies and dark matter that its gravity is literally dragging us and countless other galaxy clusters toward it. It is a bit like being in a boat on a calm lake and noticing all the floating leaves are drifting in one direction, hinting at a massive waterfall just beyond the horizon. Of course, this idea is deeply controversial. It challenges the core cosmological principle, which states that the universe should look roughly the same in every direction. If the dark flow is real, it means our universe is not uniform. It has a grand structure, a texture we are only just sensing. Skeptics have proposed other explanations, from subtle measurement errors to unknown properties of dark energy. Yet the evidence persists, a ghostly current in the cosmos, suggesting that what we call the universe might just be our local neighborhood, with untold immensities lying just out of sight. That ghostly current tugs at the universe itself, but a century ago, our own world was shaken by a single, violent impact. On the morning of June 30th, 1908, in a remote part of Siberia near the Podkamennaya Tunguska River, the sky tore open. Nomadic reindeer herders and a few scattered settlers saw a colossal blue-white fireball, as bright as a second sun, streaking across the heavens. Moments later, a shockwave of unimaginable force ripped through the air. It was so powerful it knocked people off their feet dozens of miles away and shattered windows hundreds of miles distant. The explosion registered on seismic sensors as far away as England. When scientific expeditions finally reached the epicenter years later, they found a scene of breathtaking devastation. Over 800 square miles of ancient forest were completely flattened. Millions of trees were scorched and blown down, their trunks radiating outward from a central point like a giant's matchsticks. Yet at the very heart of this destruction there was no crater. The ground was scarred and burned, but there was no hole in the earth, no telltale sign of an impact. This absence is the core of the Tunguska mystery. What could release the energy of 1,000 Hiroshima bombs without leaving a crater? The leading theory points to a cosmic intruder, most likely a stony asteroid or a fragile comet roughly the size of a 15-story building. It is thought this object was not destined to strike the ground. Instead, it entered Earth's atmosphere at a shallow angle and immense speed, superheating the air around it until the stresses became too great. It exploded in a massive fireball several miles above the surface, a phenomenon known as an airburst. The resulting blast of heat and pressure did all the damage, vaporizing the object entirely before it could hit. It was a cosmic hammer blow that never actually touched the Earth. Yet, the lack of any definitive fragments has kept other, more exotic ideas alive. Could it have been a small black hole passing straight through our planet? Or perhaps a chunk of antimatter from deep space, annihilating itself in a flash of pure energy upon contact with our ordinary matter? These are fascinating speculations, but the simplest explanation is often the most compelling. The Tunguska event serves as a stark and sobering reminder of our planet's vulnerability. If such an airburst were to happen today over a major city, the consequences would be catastrophic. The investigation continues because understanding what happened in that Siberian wilderness is not just about solving a historical puzzle. It is about preparing for our future and learning how to spot the next one before it arrives. That violent impact on Earth reminds us how much our planet is shaped by external forces, but on Mars, a far more subtle clue has scientists holding their breath. The red planet appears to be breathing, exhaling tiny puffs of a gas that should not be there. Methane has been detected in the thin Martian air, and its behavior is utterly baffling. This is not just a simple detection. Rovers like Curiosity have sniffed the air and found that the methane levels do not stay constant. They spike dramatically, rising and falling with the Martian seasons. These are not random fluctuations. They follow a predictable pattern, suggesting a process that is tied to the planet's environment. The mystery deepens because this methane does not linger. When these seasonal spikes occur, the gas seems to vanish incredibly fast, sometimes in a matter of weeks. On Earth, methane in the atmosphere can last for decades. Something on Mars is actively and rapidly destroying it, a process we do not fully understand. So where is this methane coming from, and where does it go so quickly? The potential sources fall into two dramatic categories, one geological and one that would change everything. The first possibility involves water reacting with certain types of rock deep underground. This process, called serpentinization, can produce methane as a byproduct. It is a purely chemical explanation, a sign that Mars is geologically active in ways we are still discovering. But the second possibility is what captures the imagination. On our own planet, the vast majority of atmospheric methane is produced by living organisms, from microbes to livestock. The tantalizing question is whether the same could be true on Mars. Could there be subterranean colonies of Martian microbes, tiny life forms eking out an existence deep below the frozen surface, releasing this gas as a waste product? This is the heart of the mystery. We have a signal that is both seasonal and fleeting, a potential signature of life that appears and then is scrubbed away by an unknown mechanism. It is like finding a single, fading footprint on a vast, empty beach. The evidence is maddeningly indirect. Future missions are being designed specifically to hunt for the source, to trace this ghostly breath back to its origin. Is it the faint chemical echo of a geologically active world, or is it the first whisper that we are not alone, a signal from a hidden biosphere next door? While we search for life's faint breath on Mars, far beyond the orbit of Neptune, the solar system simply seems to end. The Kuiper Belt, a vast disk of icy worlds and debris left over from the solar system's formation, does not fade away gradually into the darkness. Instead, it comes to a sudden and jarring stop, as if it has run into a cosmic wall. Astronomers call this boundary the Kuiper Belt cliff. Imagine you are walking along a beach where the sand is thick with shells, and then, without any transition, you step onto bare, smooth rock. That is what the outer edge of our solar system looks like. The number of objects drops off so drastically that it defies our basic models of how planetary systems form and evolve. This was not a discovery made by peering through a telescope's eyepiece. It was a statistical ghost revealed by years of painstaking surveys that mapped the orbits and populations of these distant, frozen bodies. The models predicted a smooth, steady distribution of objects extending much farther out. The data, however, painted a very different picture, one with a sharp and unexpected edge. So what could have carved this cliff? One of the most compelling theories points to the gravitational influence of a massive, unseen world. This hypothetical planet 9, a potential super-Earth lurking in the profound darkness, could be the architect of this boundary. Its immense gravity, the theory suggests, would act like a celestial shepherd. Over billions of years, it could have gravitationally stirred up the outer Kuiper Belt, either flinging objects into wildly different orbits, sending them crashing into the inner solar system, or even ejecting them into interstellar space entirely. This would leave behind the stark drop-off we observe today, a cleared-out zone sculpted by an invisible hand. But there is another, even more dramatic possibility. Perhaps our solar system had a close encounter in its youth. A passing star coming relatively near to our newborn sun could have ripped through the outer debris disk. Its gravity would have been like a giant plow, scattering the pristine population of icy bodies and stealing a great many of them away, leaving our system permanently truncated. This stellar flyby would have been a brief, violent event in the solar system's early history, but its signature would be frozen in time, written into the unnatural emptiness we see today. The Kuiper Belt cliff stands as a silent testament to a violent past, or perhaps a marker pointing toward a hidden present, a mystery whose solution lies in something we have yet to find. Far from the stark edge of our solar system, a world closer to home hides a storm of impossible elegance. The south pole of Venus is crowned by a colossal, double-eyed vortex, a swirling maelstrom of acid and cloud discovered by the European Space Agency's Venus Express orbiter. This is not a single, simple whirlwind like the hurricane you might picture on Earth. It is a vast figure-8 pattern, two distinct centers of rotation dancing around each other in a permanent and perfectly synchronized atmospheric ballet. The entire structure is hundreds of miles across, a permanent fixture in the planet's super-rotating upper atmosphere, where hurricane-force winds scream around the globe faster than the planet itself spins. This phenomenon is fundamentally different from the polar vortices we see on Earth or even Saturn's hexagon. Our own planet's polar vortex is a wide, cold pool of air, while the Venusian vortex is an intensely focused, dynamic, and ever-changing structure confined to the polar region. The question is, how can such a complex and violent system remain so stable for so long? The leading theories point to the planet's bizarre atmospheric circulation. On Venus, tremendous heat at the equator creates massive rising columns of air. This air then flows toward the cooler poles where it begins to sink. As it descends over the pole, the planet's rotation twists this sinking air, spinning it into a vortex, but that alone does not explain the double eye. Some scientists suggest this dual structure is a natural product of the interplay between two giant atmospheric waves. It is as if two conflicting rhythms in the atmosphere are forced to meet at the pole, and their collision results in this strange, stable dance. Another idea proposes that the vortex is constantly being fed and reshaped by smaller, chaotic whirlwinds that merge together over the pole, somehow locking into this precise configuration. Yet, the exact mechanism that creates and, more importantly, maintains this beautiful duality remains one of Venus's most guarded secrets. It is a self-organizing storm, a masterpiece of atmospheric physics that we can observe but still do not fully comprehend, a reminder that even our closest planetary neighbor holds mysteries as deep as any in the outer darkness. While the swirling vortices of Venus are a masterpiece of atmospheric chaos, deep in the cosmos another structure defies nature's usual preference for disorder with stark geometric precision. Near the star known as HD 44179, A dying sun is exhaling its outer layers into the void, creating not a billowing sphere or a ragged cloud, but the red rectangle nebula. This is not a computer-generated image or an optical illusion. It is a colossal, almost perfectly rectangular structure of glowing gas and dust, a cosmic box hanging in the darkness. Through a powerful telescope, its most striking feature becomes clear. Stretching across the shorter dimension of the rectangle is a series of faint, evenly spaced rungs, like a celestial ladder leading toward the central star. How can a star's death throes produce something so angular, so meticulously structured? The secret lies in the star itself and its unseen companion. This is not a single star, but a binary system. As the primary star nears the end of its life, it puffs away its outer layers. But instead of expanding uniformly in all directions, the gravitational influence of its partner star funnels this ejected material into two opposing cones, a phenomenon known as a bipolar outflow. We are not looking at a rectangle at all, but are viewing these two cones from the side with their wide bases nearly touching. The sharp edges and the ladder-like rungs are sculpted by an intricate dance between light, gas, and dust. Dense, dark disks of dust and gas, likely circling both stars, pinch the outflow at the waist, collimating the streams and giving the nebula its straight sides. As for the mysterious rungs, these are thought to be periodic ejections, like a series of smoke rings released at regular intervals from the central star system. Each ring expands outward, and as starlight illuminates it from within, we see the individual rungs of the cosmic ladder. This incredible structure is a temporary phenomenon, a fleeting moment in a stellar life cycle that will last only a few thousand more years before the central star heats up and transforms the red rectangle into a more typical planetary nebula. Its existence challenges our assumptions about cosmic chaos, proving that under the right conditions, the universe can craft forms of breathtaking order, a perfect geometry written in the final breath of a dying sun. Our own moon, a world we have walked upon, holds its own repertoire of ghostly lights. For centuries, astronomers have recorded brief, unexplained flashes and dim glows flickering across its dark plains and deep inside its craters. These are the transient lunar phenomena, elusive events that can last from a few seconds to several hours, appearing as sudden brightenings, reddish hazes, or patches of obscuring mist. The famous astronomer Sir William Herschel in the 1700s reported seeing points of light on the moon he believed were volcanic eruptions. More recently, before the Apollo landings, NASA even compiled a catalogue of these anomalies to help assess potential risks for astronauts. The events are real, but their causes remain deeply uncertain. One of the leading theories points to outgassing. The moon is not entirely geologically dead. Radon gas, a radioactive element, has been detected seeping from its interior. It is possible that subsurface pockets of gas trapped since the moon's formation occasionally find a weak spot in the crust and vent into the vacuum of space. When these trapped gases are suddenly exposed to sunlight, they could theoretically glow for a brief period before dispersing into the void. Another, more straightforward explanation is meteorite impact. The moon has no atmosphere to protect it, so even small space rocks strike its surface with tremendous force, creating instantaneous, incandescent flashes of vaporized rock. These impact flashes are regularly observed during meteor showers when the Earth and Moon plow through the same cloud of debris. Yet a third possibility involves electrostatic phenomena. The lunar surface, constantly bathed in solar radiation, can build up powerful electric charges. Scientists speculate that this static electricity could potentially cause dust to levitate, creating temporary, shimmering clouds above the ground that could scatter light in strange ways. So why, with all our modern telescopes and orbiting spacecraft, are these events so difficult to confirm? The challenge is their sheer unpredictability and brevity. Pointing a powerful telescope at one specific crater for months might yield nothing, while a brilliant flash might occur in an unobserved region just moments later. Furthermore, Earth's own turbulent atmosphere distorts our view, making it hard to distinguish a true lunar glow from a fleeting atmospheric shimmer. These phantom lights represent a fundamental puzzle. Is the moon still subtly active, breathing traces of its ancient volatile elements into space? Or are we simply witnessing the constant, natural bombardment of a world without an air blanket? The flashes continue to appear, silent and unannounced, reminding us that even the most familiar object in our night sky has not yet yielded all of its secrets. While the moon's ghostly lights flicker and fade, Jupiter hosts a tempest so vast and ancient it makes every other storm in the solar system seem like a fleeting breeze. This is the Great Red Spot, a colossal, swirling vortex of clouds that has raged for at least 4 centuries. Its scale is almost beyond comprehension. For most of recorded history, this single storm was wide enough to swallow 2 or even 3 Earths side by side. It is a perpetual hurricane of unimaginable ferocity, with winds screaming at speeds that can exceed 400 miles per hour, yet it is trapped, pinned in place by the jet streams of Jupiter's southern hemisphere. The most profound mystery is not its power, but its longevity. How can a storm like this persist for hundreds of years when even the most powerful hurricanes on Earth dissipate after a few weeks? The secret may lie in the storm's structure and its energy source. Unlike earthly storms, which feed off the heat of the ocean and are disrupted by friction with land, the Great Red Spot is a purely atmospheric phenomenon. It is thought to be a massive anticyclone, a high-pressure storm that acts like a self-sustaining atmospheric engine. It draws its energy not from below, but from the sides, feeding on the smaller storms and turbulent eddies that it constantly absorbs from the surrounding jet streams. It is a predator of storms, growing and maintaining its fury by consuming the chaos around it. Yet, this ancient behemoth is changing. For decades, astronomers have watched it shrink. Once a sprawling oval, it has become more circular, and its iconic brick red color has faded to a pale salmon hue at times. These changes hint at the complex and poorly understood chemistry occurring deep within the storm's cloud layers. The red color is likely caused by chemicals being upwelled from Jupiter's warmer interior and broken apart by solar ultraviolet radiation. But why the intensity of this process fluctuates remains unknown. The shrinkage is even more puzzling. Is the spot slowly dying, finally losing its battle against the atmospheric forces that have sustained it for so long? Or is this simply part of a natural, centuries-long cycle of contraction and expansion that we are only now witnessing for the first time? Its eventual fate is a wide-open question. Will it continue to shrink until it vanishes entirely, or will it find a new equilibrium and persist for another 400 years? The Great Red Spot is more than just a storm. It is a living laboratory of fluid dynamics on a planetary scale, a testament to the sheer, raw power of a gas giant's atmosphere, and a humbling reminder that some of the solar system's greatest wonders are also its most ephemeral. Jupiter's storm is a titan of the present, but Earth's own climate holds a mystery from the deepest past. Our planet should have been a frozen snowball for much of its early history. The problem lies with the Sun itself. Billions of years ago, our star was significantly fainter, shining with only about 70% of the brightness it has today. According to every basic calculation, that level of solar energy was insufficient to keep Earth's surface above the freezing point of water. And yet, the geological record tells a completely different story. We find ancient rocks, some over 3.8 billion years old, that show clear signs of being shaped by liquid water. There are ripple marks preserved in stone and minerals that can only form in the presence of flowing liquid water. This is the faint young sun paradox, a direct conflict between our understanding of stellar evolution and the clear evidence written in Earth's oldest stones. So how was our planet kept warm? The most widely accepted solution points to a supercharged greenhouse effect. In its youth, Earth's atmosphere was likely far thicker with heat-trapping gases like carbon dioxide and methane. These gases would have acted like an insulating blanket, trapping the sun's weaker heat and preventing the planet from freezing solid. Think of it like wearing a heavy coat on a cold but sunny day. The coat keeps your body heat from escaping, keeping you warm even though the sunlight itself is weak. But this elegant solution brings its own set of puzzles. The geological evidence does not show the massive amounts of carbon dioxide that such a theory would require. There are no vast limestone deposits from that era that would indicate an atmosphere choked with CO2. This has led scientists to consider other, more potent greenhouse gases like methane, which could have been produced by early microbial life. Perhaps life itself was the thermostat, with ancient organisms releasing enough methane to keep their own world habitable. This introduces a fascinating possibility that biology and geology worked in a delicate partnership to regulate the planet's temperature from the very beginning. Yet the calculations remain precarious. Getting the balance right is incredibly difficult. Too much greenhouse gas and the planet would have overheated into a runaway hothouse. Too little and it would have become a permanent ice ball. The faint young sun paradox is more than just a historical curiosity. It is a fundamental puzzle about planetary climate stability. Solving it does not just tell us about our own past, it provides a crucial framework for understanding the potential for life on worlds orbiting other, fainter stars. How exactly did our planet thread the needle to become a cradle for life, when by all rights it should have been a frozen wasteland? Even as we ponder the warmth of a faint young sun, our solar system extends into a profound and almost mythical darkness. Far beyond the orbits of the planets, beyond even the sharp cliff of the Kuiper Belt, lies a theoretical realm known as the Oort cloud. This is not a place we can see or visit. It is a ghostly shell of trillions of icy objects, a vast spherical swarm that is thought to encase our entire solar system, marking the true outer boundary of the sun's gravitational influence. Its existence is inferred from the long-period comets that occasionally streak into our inner solar system. These comets, with orbits that can take thousands or even millions of years to complete, do not come from the flat disk of the Kuiper Belt. They arrive from every possible angle, suggesting a spherical reservoir of icy bodies surrounding us. The central mystery is how this cloud of frozen remnants came to be so incredibly far away. The sun's birthplace was a crowded stellar nursery, a cluster of thousands of newborn stars packed closely together. In this dynamic environment, the gravitational pull of passing sibling stars could have played a crucial role. One theory suggests that the young sun's own giant planets, like Jupiter and Saturn, acted as gravitational slingshots. They may have flung countless icy planetesimals from the inner solar system out into the abyss, but the gravity of a nearby star in the cluster would have gently captured these ejected objects, trapping them in the distant, loosely bound halo we call the Oort cloud. An even more radical idea proposes that the sun did not form all of this material itself. In the close quarters of the stellar nursery, the sun could have gravitationally stolen trillions of comets from the outer regions of other newborn star systems, building its own cloud from the icy debris of its neighbors. This would mean that some of the comets visiting us today could be interstellar immigrants captured in that long-ago era. The greatest challenge is that the Oort cloud is simply too distant and its objects too dark and tiny to be seen with our current telescopes. We are trying to study a cosmic structure by observing the rare and fleeting visitors it sends our way, like trying to map an entire forest by studying a few leaves that have blown into our backyard. This invisible envelope of ice holds the pristine records of our solar system's violent and crowded birth, a frozen archive of our true beginnings, forever lingering at the very edge of our perception. As our spacecraft venture into the void, they sometimes whisper secrets we did not expect to hear. The Pioneer 10 and 11 probes, after completing their missions to the outer planets, became the most precise navigational experiment in history as they coasted toward interstellar space. Yet, as scientists tracked their positions over billions of miles, a tiny but persistent anomaly emerged. Both spacecraft were experiencing a mysterious, constant deceleration, a slight but undeniable tug back toward the Sun. The force was incredibly faint, just a 10 billionth of the gravity we feel on Earth, but it was there, acting on both probes in exactly the same way. For years, this pioneer anomaly fueled intense speculation. Had we stumbled upon a flaw in our understanding of gravity itself? Could Einstein's theory of general relativity need a revision for the vast, empty stretches of the solar system? Perhaps some unknown form of dark matter was exerting a subtle drag. The mystery deepened with every data point, a ghostly force acting from the shadows. The solution, when it finally came, was a triumph of meticulous detective work, but it emerged from an utterly mundane source: heat. The probes were powered by radioactive generators, and this produced a steady, waste heat that the spacecraft radiated into space. Scientists realized that this thermal radiation was not perfectly symmetrical. A little more heat was being emitted from the back of the spacecraft than from the front. This imbalance created a tiny but continuous thrust, a photon pressure that acted like a faint brake, perfectly accounting for the observed deceleration. It was the spacecraft's own warmth gently pushing them backward. Yet, even after this thermal recoil force was fully calculated, a minuscule fraction of the anomaly remained unexplained. This tiny residual, a whisper within a whisper, continues to intrigue some scientists. Could it be mere noise in the data, or might it be the faint signal of something else entirely, a nudge from a force we have not yet named? The pioneer anomaly serves as a profound lesson, a reminder that even in the grand emptiness of space, the answers to our biggest mysteries can sometimes be found in the smallest, most overlooked details. Even as our spacecraft drift into the void, they are struck by invisible bullets from the depths of space. These are cosmic rays, atomic nuclei accelerated to nearly the speed of light, and they are constantly raining down on our solar system from every direction. For decades, we assumed we had a basic understanding of their behavior, but our most sensitive instruments have revealed a startling anomaly. Far out in interstellar space, the Voyager probes detected something unexpected, a persistent and significant excess of high-energy cosmic rays. This was not the smooth, predictable distribution scientists had anticipated. It was as if the probes had sailed past the protective bubble of our Sun's influence, the heliosphere, only to find a hidden reservoir of intense radiation lapping at its shores. The mystery only deepened closer to home. The Alpha Magnetic Spectrometer, a state-of-the-art particle detector mounted on the International Space Station, has confirmed this strange surplus with incredible precision. It measures an overabundance of these high-energy particles, a signal that defies our standard models of cosmic ray propagation. The central question is a profound one: what cosmic particle accelerator is responsible for this relentless, energetic barrage? One compelling theory points to a recent, nearby supernova. If a massive star exploded within the last few million years relatively close to our solar system, its expanding shockwave could still be acting like a colossal particle collider, continuously pumping energy into atomic nuclei and flinging them in our direction. We might simply be living in the aftermath of a stellar cataclysm, feeling the lingering echoes of the blast, but there is another, more exotic possibility lurking in the data. This unexplained excess has all the hallmarks of a process physicists have long sought: the annihilation of dark matter. This invisible substance, which makes up most of the mass in the universe, could be concentrated in a halo around our galaxy. If two dark matter particles were to collide and destroy each other, the event could release a burst of energy, creating the very high-energy cosmic rays we detect. The anomalous rays could be the first indirect evidence of this mysterious substance, the ghostly fingerprint of dark matter revealing itself through its own destruction. Yet the source remains maddeningly elusive. The paths of these charged particles are scrambled by the magnetic fields that fill interstellar space, making it impossible to trace them back to a single point of origin. They arrive at our detectors from everywhere and nowhere at once, a cosmic background noise with a hidden, powerful signal buried within. Are we witnessing the final tremors of a long-dead star, or are we on the cusp of identifying the fundamental nature of the universe's missing mass? This invisible rain holds the answer, a secret carried on particles smaller than an atom. The invisible rain of cosmic rays is a mystery of particles, but the next cosmic puzzle is written entirely in light, or rather, the inexplicable absence of it. A star named Cassi 8462852, better known as Tabby's star, began behaving in a way that defied every known category of stellar behavior. Data from the Kepler Space Telescope revealed its light was not just flickering, it was plunging. This was not the gentle, rhythmic dip of a planet passing in front, but massive, irregular blockages of the star's light, with the brightness sometimes dropping by a staggering 22%. That is an immense amount of light to vanish, far more than even a giant planet could obscure. The dimming events were also completely aperiodic, arriving at random intervals and lasting for wildly different lengths of time, from days to weeks. It was as if something colossal and shapeless was drifting erratically in front of the star, a cosmic phantom blotting out its sun. The hunt for a conventional explanation began immediately. Could it be a vast, chaotic swarm of comets, thousands of them, breaking apart and casting immense shadows? While this idea can theoretically create irregular dimming, the sheer scale required is almost unbelievable, a level of cometary activity never before observed around any star. The dust from such a swarm should also glow brightly in infrared light as it heats up, and follow-up observations found far less of this infrared signature than the comet theory demanded. With every natural explanation straining under the weight of the data, a more sensational possibility captured the public imagination: alien megastructures. The concept, drawn from science fiction, is a Dyson swarm, a vast collection of energy-capturing panels orbiting a star to harness its total power. Such a colossal, artificial construction would indeed cause the deep, irregular dimming patterns we see, as different parts of the structure rotated in and out of view. It was a hypothesis born of sheer desperation, a thought experiment that suddenly seemed less outlandish when faced with a star that obeyed no known natural law. Subsequent observations have continued to deepen the mystery without solving it. The star has also been shown to be very slowly dimming over years, a long-term fade that adds another layer of complexity. While the megastructure idea remains the most speculative of all, no purely natural model has yet emerged that can comfortably account for the star's entire bizarre light curve. The data itself is not wrong, our models are simply incomplete. Tabby's star stands as a permanent challenge, a celestial beacon that refuses to be easily categorized, forcing us to question whether we are witnessing an utterly new type of astrophysical event or something else entirely. While one star flickers with inexplicable shadows, another world in our own system spins on its side in a permanent state of cosmic confusion. Uranus is the solar system's oddball, a planet that rolls around the sun like a ball on a circular track, its axis tilted by a staggering 98 degrees. This is not a slight wobble, it is a complete and total reorientation. Its north pole points almost directly at the sun during its solstice, leaving one hemisphere bathed in constant daylight for 21 years while the other half endures a decades-long frigid night. The leading theory for this bizarre posture is as dramatic as it sounds: a colossal impact. Early in the solar system's violent youth, a protoplanet perhaps as large as Earth itself is thought to have slammed into Uranus. This was not a glancing blow, but a direct, shattering hit that effectively knocked the entire world over, leaving it spinning on its side. The evidence for this is compelling, but the implications create new puzzles of their own. If such a giant impact occurred, it should have sent the planet's system of moons into complete disarray. Yet, Uranus's major moons orbit neatly around its new, tilted equator, as if they formed from the debris of the impact itself, a disk of shattered material that coalesced into new worlds after the cataclysm. This elegant solution, however, runs into trouble with the planet's bizarre magnetic field. Unlike Earth's relatively straightforward magnetic poles, which align roughly with our rotational axis, Uranus's magnetic field is a tangled mess. It is both offset from the planet's center and tilted at a wild 60-degree angle from its rotational axis. It is as if the planet has two north poles, one for its spin and one for its magnetism, and they are in a constant, lopsided dance. A single, giant impact makes it very difficult to explain how such a complex and off-kilter magnetic field could have been generated and sustained deep within the planet's icy interior. The mystery of Uranus's tilt is therefore more than just a question of what knocked it over. It is a puzzle of timing, of formation, and of internal dynamics. Did the impact happen so early that it completely reshaped the planet's core and its subsequent magnetic field? Or are we witnessing the aftermath of multiple, smaller collisions that gradually pushed the world onto its side? The violent birth hypothesis remains the best story we have, but it is a story with missing chapters, a celestial crime scene where the evidence points to a catastrophic event, but the exact weapon and the sequence of events remain frustratingly just out of reach. Even the majestic rings of Saturn are not the permanent fixtures they appear to be. They are actively disintegrating, caught in a slow but relentless downpour onto the planet below. The Cassini spacecraft made this startling discovery during its final, daring orbits, diving between the rings and the planet's cloud tops. Its instruments detected a shower of charged water particles, ice crystals, and organic molecules streaming from the inner rings directly into Saturn's upper atmosphere. This is not a gentle mist, but a constant, heavy rain, with an estimated 10,000 kilograms of ring material crashing down every single second. That is enough to fill an Olympic-sized swimming pool with icy debris in a matter of hours, a deluge that has been ongoing for eons. This ring rain is sculpted by Saturn's own powerful magnetic field. The field lines act like invisible highways, channeling the tiny, electrically charged ice grains from the rings and funneling them toward the planet's polar regions. Where these particles strike the upper atmosphere, they create a glowing, hot band, a visible scar of this cosmic precipitation. This influx of foreign material is fundamentally changing the chemistry of Saturn's high atmosphere, increasing its density and altering its carbon and oxygen content in ways we are still trying to understand. The most profound implication, however, is for the rings themselves. This constant erosion means they are living on borrowed time. Based on the measured rate of this downpour, scientists estimate the rings could be completely gone in another 100 million years. That may sound like a long time, but on the cosmic scale, it is a blink of an eye. This leads to a startling conclusion about their age. If they were as ancient as the solar system itself, over 4.5 billion years old, they would have vanished long ago under such an assault. Their continued existence and vibrant appearance suggest they are relative newcomers, perhaps forming only a few 100 million years ago from the breakup of an icy moon or a captured comet. The beautiful, iconic rings we see today are not a primordial feature, but a temporary, dazzling spectacle, a fleeting crown for a giant planet, reminding us that even the most seemingly eternal structures in our solar system are in a constant, dynamic state of change. The dazzling rings of Saturn are a spectacle of impermanence, but deep in the asteroid belt, another world gleams with points of concentrated light. The dwarf planet Ceres, the largest object between Mars and Jupiter, was thought to be a dark, frozen relic. That assumption shattered when the Dawn spacecraft arrived in 2015 and gazed into the Ocata crater. There, scattered across its dark floor, were brilliant, unexplained bright spots, shining like celestial headlights in the void. The most prominent pair, named Cerealia facula and Venalia faculae, were dazzlingly reflective, making Okata one of the brightest features in the entire asteroid belt. Dawn's close inspection revealed their composition. They were vast deposits of sodium carbonate, a kind of salt you might find in a drying lakebed on Earth. But this was not Earth, and the presence of this glistening salt on a cold, small world was a profound mystery. How did it get there? The leading theory points to a form of icy volcanism. Ceres is rich in water ice, and scientists believe it might harbor a deep, subsurface reservoir of briny water. In the distant past, a massive impact that created the Okata crater could have fractured the crust, allowing this salty sludge to well up from below. When the brine reached the airless, frigid surface, the water would have quickly sublimated, vanishing into space and leaving behind the brilliant, salt-rich residue we see today, a sparkling stain on the crater floor. But the intrigue does not end with a single ancient event. The stunning brightness and crisp appearance of the deposits suggest they are remarkably young, perhaps only a few million years old. This points to the possibility that Ceres is not a dead world, but a geologically active one. The process might be ongoing, with sporadic eruptions or oozing brines still occasionally refreshing these bright spots, preventing them from being darkened by the constant rain of cosmic dust. This raises a tantalizing question: what is the source of energy driving this activity? Is there still enough internal heat left from Ceres's formation to power these eruptions, or could the freezing and thawing of a deep, global ocean be creating the pressure needed to force the brine to the surface? These gleaming spots are more than just a strange geological curiosity. They are a beacon pointing toward a potentially dynamic world with a subsurface reservoir of liquid water, a key ingredient for life as we know it. That gleaming salt on Ceres is a signature of hidden water, but our own star possesses a heat signature that defies all logic. The surface of the Sun broils at a temperature of around 10,000 degrees Fahrenheit, a searing heat that seems impossible to surpass. Yet, just above this visible surface, in the wispy outer atmosphere called the corona, the temperature skyrockets. It soars to millions of degrees, creating a halo of unimaginable heat that extends millions of miles into space. This is the coronal heating problem, a paradox that has baffled physicists for decades. How can the atmosphere be hundreds of times hotter than the surface itself? It is as if the air around a flame were suddenly far hotter than the fire. This mystery was not solved by staring at the Sun from Earth, but by sending probes on daring missions directly into the solar inferno. Spacecraft like NASA Parker Solar Probe are flying through the corona itself, enduring brutal heat to taste the solar wind and measure the magnetic fields up close. The data points to the Sun's churning magnetic field as the ultimate source of this immense energy. One leading theory involves a process called magnetic reconnection. The Sun's surface is a tangled web of powerful magnetic field lines. These lines are constantly crossing, breaking, and violently reconnecting with each other. This reconnection acts like a colossal slingshot, releasing enormous bursts of energy in an instant. Think of it as twisting a rubber band tighter and tighter until it suddenly snaps, unleashing all its stored energy at once. These explosions, while smaller than massive solar flares, could be happening everywhere all the time in the form of countless nanoflares. A constant, invisible rain of these tiny explosions might be the furnace that heats the entire corona. Another idea focuses on powerful waves. The Sun's convective surface is like a pot of boiling water, constantly churning and generating powerful waves that travel upward along the magnetic field lines. As these waves rise into the much thinner corona, their energy, which started as motion, could be dissipated as intense heat, like ocean waves crashing onto a shore and generating tremendous friction. The true answer might be a complex combination of both mechanisms, a symphony of waves and magnetic explosions working in concert. Yet, precisely quantifying this energy transfer remains the greatest challenge. We can see the effects, but we cannot yet fully trace the path of the energy from the Sun's interior to its outer atmosphere. Solving this puzzle is not just an academic exercise. The superheated corona is the source of the solar wind, a constant stream of charged particles that flows throughout our solar system. When this wind interacts with Earth's magnetic field, it can create beautiful auroras, but intense solar storms can also disrupt satellites, knock out power grids, and endanger astronauts. Understanding how the corona is heated is the key to predicting the Sun's behavior, a crucial step in protecting our increasingly technological civilization from the star that gives us life. While the Sun's corona blazes with paradoxical heat, the farthest ice giant from its warmth also burns with a mysterious inner fire. Billions of miles from the Sun, where sunlight is little more than a bright star in a perpetual twilight, Neptune should be a frozen, dormant world. Yet the Voyager 2 probe revealed a stunning truth. Neptune is not cold and still, it is a cauldron of violent weather, with the fastest winds in the solar system screaming at over 1,200 miles per hour. Even more baffling is its energy budget. The planet radiates more than twice the amount of heat into space than it receives from the distant Sun. This is the Neptune heat anomaly, a deep and persistent energy surplus with no simple explanation. Where is all this extra heat coming from? The leading theory points to the planet's own slow and violent birth. As Neptune coalesced from the primordial cloud of gas and dust, immense gravitational forces crushed its core. That process of formation generated a tremendous amount of heat that has been trapped inside the planet for billions of years. Now, as the planet continues to cool down over eons, it is gradually releasing that stored thermal energy, a process known as gravitational contraction. Think of it like a baked potato taken out of the oven. It continues to radiate heat for a long time after the external heat source is gone. Another potential contributor is radioactive decay. Heavy elements like uranium and thorium, locked deep within Neptune's rocky core, could be slowly breaking down and releasing heat as a byproduct, providing a steady internal nuclear furnace. But these explanations, while logical, run into a major puzzle. Neptune's twin, Uranus, is nearly identical in size and composition, yet it shows almost no excess heat at all. Why would one ice giant be boiling with inner energy while the other is thermally quiet? This discrepancy suggests that a catastrophic event in the solar system's past, like the colossal impact that knocked Uranus on its side, may have also scrambled its internal structure, releasing its primordial heat in one violent burst and leaving it thermally dead. Neptune perhaps was spared such a trauma and has been cooling slowly and steadily ever since. The intense weather, driven by this internal heat rising through layers of slushy ice and supercritical fluids, creates a complex system we can barely simulate. The exact mechanism that translates this deep warmth into supersonic winds and massive, fleeting dark storms remains one of the great unsolved puzzles of planetary science, a reminder that even in the deepest freeze, a world can hold a fiery heart. Beyond the scattered ice of the Kuiper Belt, the gravitational signature of a ghost world has astronomers tracing patterns in the dark. The evidence for Planet 9 is not a direct image, but a story written in the skewed paths of the most distant known objects in our solar system. These extreme trans-Neptunian objects do not orbit randomly. Their elongated paths are mysteriously clustered, as if an unseen shepherd is herding them, aligning their orbits so their closest approaches to the Sun all lie in roughly the same direction. The odds of this alignment happening by pure chance are astronomically low. Something massive must be gravitationally influencing them, keeping their chaotic dances in a strange, coordinated formation. This hypothetical planet is no small world. Based on the gravitational tug required to orchestrate these distant orbits, scientists predict a super-Earth, a world up to 10 times the mass of our own, tracing a vast, elliptical path that takes it 10 to 20,000 years to complete a single journey around the Sun. Its orbit would be tilted, carrying it high above and far below the flat plane where the other planets reside, which is precisely why we have not found it yet. Our surveys have largely focused on the ecliptic, the solar system's main street. While this recluse wanders the celestial backroads, the hunt for Planet 9 is a painstaking process of scanning enormous swaths of the sky for a single, faint, slow-moving point of light. Powerful telescopes like Subaru on Mauna Kea are engaged in this cosmic treasure hunt, comparing images taken nights or weeks apart to catch any object that has shifted its position against the fixed background of stars. It is a needle in a haystack the size of the sky, yet the gravitational evidence remains compelling, forcing us to consider a profound possibility that our solar system's planetary census is incomplete. Of course, such a radical claim invites skepticism and alternative explanations. Could the observed orbital clustering be an observational bias, a trick of where we have pointed our telescopes? Perhaps the collective gravity of countless smaller, unseen Kuiper Belt objects, a vast swarm of unseen ice dwarfs, could be exerting a gentle but persistent pull that mimics the effect of a single large planet. This idea of a collective gravitational influence is intriguing, but it requires a tremendous amount of unseen mass distributed in a very specific way, a hidden disk of material we have not yet detected. The Planet 9 hypothesis stands as the most elegant solution, a single culprit for a series of gravitational anomalies. Is a true giant lurking in the frozen darkness a relic from the solar system's birth, or are we being fooled by the faint whispers of a countless, unseen multitude? The search continues, a testament to the fact that the most massive discoveries can still be hiding in the last places we think to look. Another world in our own cosmic backyard is adorned with ghostly, painted brushstrokes. These are the lunar swirls, some of the most beautiful and baffling patterns in the entire solar system. They look like celestial cream swirls spilled across the moon's dark gray plains, bright, sinuous features that can stretch for hundreds of miles. The most famous, Lunar Gamma, is a dazzling, tadpole-shaped formation that almost seems to glow against the surrounding Maria. For a long time, their origin was a complete mystery, but we now know one crucial fact. These bright swirls are almost perfectly aligned with powerful, localized magnetic fields. The Moon has no global magnetic shield like Earth, but it does possess these intense, isolated magnetic bubbles, and wherever one of these bubbles exists, a bright swirl almost always accompanies it. So how does a magnetic field create a bright pattern on the ground? The leading theory is that these magnetic anomalies act as a miniature sunscreen for the lunar soil. The Moon's surface is constantly bombarded by the solar wind, a relentless stream of charged particles from the Sun. This bombardment has a darkening effect on the lunar regolith, the layer of dusty soil over billions of years. But when this solar wind approaches one of these magnetic bubbles, the charged particles are deflected. They flow around the protected zone, much like water parting around a rock in a stream. The soil sheltered beneath this magnetic umbrella is spared the darkening process, remaining bright and reflective while the land around it slowly weathers and darkens. This creates the stunning, high-contrast patterns we see from orbit. Yet this elegant explanation only deepens the core mystery. Where did these powerful, localized magnetic fields come from in the first place? One dramatic hypothesis points to a violent birth. The swirling pattern of Lunar Gamma sits directly opposite the massive Imbrium impact basin on the far side of the Moon. It is possible that the colossal impact that created Imbrium sent a titanic shockwave through the entire Moon. This shockwave could have compressed and amplified pre-existing pockets of magnetic material in the crust, turning them into the powerful, focused magnets we detect today. Another compelling idea involves a more direct cosmic artist, a comet. A comet's nucleus is a fragile mixture of ice and dust, and if one struck the moon at a shallow angle, it might not have created a traditional crater. Instead, it could have vaporized instantly upon impact, its dust and gases spreading out in a swirling plume that settled back onto the surface. This fine, bright cometary dust could have coated the existing regolith, and the impact itself may have even magnetized the soil beneath it through the intense heat and pressure. The greatest puzzle, however, is their preservation. The moon is a world without air or water, but it is still subject to a constant, gentle rain of micrometeorites and cosmic dust that should, over millions of years, have mixed the bright and dark soils together, blurring the sharp edges of the swirls into obscurity. The fact that they remain so starkly defined suggests they are either much younger than we think, or some ongoing process, perhaps linked to those magnetic fields, is actively preventing them from being erased. Are we looking at the frozen scars of ancient cataclysms, or are these magnetic sunscreens still actively at work, preserving these enigmatic masterpieces against the slow fade of time? Those ghostly brushstrokes on our moon are a mystery of preservation, but another moon in our system is etched with scars that seem to defy all logic. Circling Mars is the tiny, lumpy moon Phobos, and its entire surface is covered in a network of strange, parallel grooves. These are not random cracks. They are precise lines running side by side like the tracks of a cosmic plow, some stretching for miles across the dusty terrain. For decades, these grooves have presented a stark puzzle, an unnatural pattern on a world barely 17 miles across. The most prominent theory connects these lines directly to the moon's grim future. Phobos is spiraling slowly inward toward Mars, drawn by immense tidal forces. As it gets closer, the red planet's gravity exerts a stronger and stronger pull, stretching and squeezing the small moon. This constant stress, scientists suggest, could be causing the entire body to slowly fracture from within. The grooves may be the surface expression of these deep-seated tidal stresses, like the first cracks appearing in a piece of glass that is being steadily squeezed. They could be stress fractures, a preview of the moon's eventual destruction when Mars's gravity rips it apart entirely. A second, more direct explanation points to a colossal impact. Phobos bears a massive crater named Stickney, an impact so violent it nearly shattered the moon. The grooves, particularly those radiating directly from the crater, could be chains of secondary craters. When the Stickney impact occurred, it would have hurled immense boulders and debris across the surface. These projectiles, skimming and bouncing, could have carved out the parallel lines we see today, a permanent record of that ancient cataclysm. Yet there is a third, more speculative idea. What if Phobos is not a captured asteroid held together by its own gravity, but a rubble pile, a loose collection of rocks and dust barely clinging together? In this scenario, the grooves could be the surface traces of deep internal fractures, the seams where the larger chunks of this celestial aggregate are joined. The debate continues because each theory has its own flaws. If the grooves are tidal stress fractures, why are they so uniform and surface level, and why do some clearly seem related to the Stickney crater? If they are solely from the Stickney impact, why do so many grooves exist that have no clear connection to the crater, and why do they cover the entire moon so systematically? The true answer might be a complex combination, a world first shattered by an impact and now slowly being pulled apart by its planet. The grooves of Phobos are more than just curious lines. They are a celestial autopsy, a map of both a violent past and an inevitable future, written on a moon that is living on borrowed time. The strange grooves on Phobos map a local mystery, but our solar system has recently welcomed travelers from a far more distant shore. In 2017, astronomers spotted an object hurtling through our cosmic neighborhood at a speed so high it could only have one origin: interstellar space. This was Oumuamua, the first known visitor from another star system. Its arrival was a landmark event, but its properties were baffling. observations revealed it was not a typical comet, showing no signs of a fuzzy coma or a tail as it swung around the sun. Yet something was pushing it. Precise tracking showed it was experiencing a tiny but persistent acceleration, as if an unseen force was gently giving it an extra push on its way out. The most conventional explanation points to comet outgassing. If Oumuamua was made of icy material, the sun's heat could have caused hidden jets of gas to erupt from its surface. This outgassing would act like a natural thruster, providing the slight acceleration without producing a visible dust cloud, especially if the object was very old and its ices were mostly depleted. But this theory struggles to explain its other bizarre trait, its shape. The way its brightness changed as it tumbled suggested an extreme, elongated form, perhaps 10 times longer than it was wide, like a cosmic cigar or a pancake tumbling through the void. No known asteroid or comet in our solar system has such a dramatic proportions. The combination of its strange acceleration and its peculiar shape led to more exotic speculations. Could it be a chunk of pure hydrogen ice, a type of object never seen before, slowly evaporating in the sunlight? Or, in the most sensational hypothesis, was it a light sail, a piece of alien technology drifting through the galaxy? While the alien artifact idea is a captivating thought experiment, most scientists lean toward natural, if unusual, explanations. Oumuamua's true nature remains a subject of intense debate precisely because it was already leaving our solar system when we found it, a fleeting glimpse of a mystery we could not hold on to. Then, just 2 years later, a second interstellar traveler arrived. 2I/Borisov looked and behaved exactly like a comet should, with a brilliant coma and a distinct tail of gas and dust. Its normalcy was, in its own way, just as profound as Oumuamua's strangeness. It confirmed that our galaxy is teeming with such icy wanderers, and that Oumuamua was likely the outlier. Together, these two visitors tell a story of planetary systems beyond our own. Their existence implies that the process of planet formation around other stars must be a chaotic and violent affair, flinging countless trillions of objects out into the galactic void. Oumuamua, a possible rocky or icy shard, might be a fragment of a shattered world, while Borisov is a pristine sample of the icy building blocks of planets. They are celestial messages in a bottle, carrying with them the chemical fingerprints of their long-vanished stellar nurseries. Their brief passage through our neighborhood forces a humbling realization. Our solar system is not an isolated island, but part of a vast, interconnected archipelago of stars, constantly exchanging material across the light years. But the ultimate source of these mysterious particles is not the only puzzle they present. As we map their arrival with ever greater precision, another strange pattern emerges from the noise. The most powerful cosmic rays do not strike Earth evenly from all directions. Instead, they show a distinct and unexpected imbalance, a cosmic lopsidedness that astronomers call the galactic cosmic ray anisotropy. For years, our models assumed that these ultra-high-energy particles, having traveled millions of light years, would be thoroughly scrambled by the Milky Way's tangled magnetic fields. They should arrive at our detectors as a uniform, featureless drizzle from every corner of the sky. Yet, massive observatories like the Pierre Auger Observatory in Argentina, with its thousands of square kilometers of detectors, have painted a very different picture. The data reveals a significant dipole anisotropy, a broad, faint pattern in the sky where more of these particles are coming from one general direction and fewer from the opposite. It is as if you were standing in a gentle rain and realized the drops were consistently striking your left shoulder more often than your right. This subtle but persistent directional bias should not exist if our understanding of the galaxy's magnetic maze is correct. Those fields are incredibly powerful, and they should bend the paths of these charged protons and atomic nuclei so severely that any memory of their original source is completely erased. The fact that we can detect this pattern means the particles are not being randomized as thoroughly as we thought. their paths across the galaxy retain a faint imprint of their origin. So what is causing this directional whisper? One possibility is that the sources of these ultra-high-energy rays are not randomly scattered throughout the universe, but are clustered relatively nearby on a galactic scale. We might be sitting in the outskirts of a local bubble of cosmic ray accelerators, perhaps a group of active galaxies or a recent series of supernova explosions in our galactic neighborhood. Their combined output could be creating a detectable gradient, a slight excess from their general direction. Another compelling idea involves the magnetic field of our own Milky Way itself. This field is not a simple, neat bar magnet. It is a chaotic web with some regions acting as magnetic highways that channel particles more efficiently, while other areas create bottlenecks or dead ends. The anisotropy we observe could be a map of this invisible infrastructure, a shadow play showing us how the galaxy's magnetic skeleton guides the most energetic particles in the universe. Yet, even with these ideas, the models struggle to fully reproduce the observed signal. The imbalance is there, a clear statistical ghost in the data, but its origin remains just out of reach. This anisotropy is more than a minor correction to our maps. It is a fundamental challenge to our picture of how matter and energy flow through the cosmos. It suggests that the galaxy is not a perfectly mixed cocktail, but has currents and textures we are only beginning to sense. By listening to the directional whisper of these atomic bullets, we are learning to read the hidden magnetic language of the galaxy itself. From the hexagonal storm at Saturn's pole to the ghostly tug of the dark flow, these 25 cosmic riddles reveal a solar system brimming with secrets. We have wandered past worlds that breathe methane, stood before the stark cliff at the edge of our planetary system, and listened for a signal that never returned. We have witnessed the fleeting beauty of Saturn's rings and the ancient fury of Jupiter's great red spot, all while realizing that our most fundamental assumptions about warmth, gravity, and even the stability of our own sun can be upended by a single, strange observation. Each of these phenomena is a question mark written across the cosmos, a reminder that our understanding is not a finished book, but a living, breathing draft constantly being revised. These are not dead ends, they are the very engines of scientific discovery. Every unexplained flash of light on the moon, every skewed orbit in the Kuiper Belt, is a beacon calling us to look deeper, to question more boldly, and to build the next generation of probes and telescopes that will turn today's mysteries into tomorrow's revelations. Our cosmic backyard is far from fully explored, and its greatest wonders may still be waiting for a curious mind to finally notice them. So we turn this final question to you: which of these 25 enigmas captures your imagination the most? Is it the impossible geometry of the Red Rectangle Nebula, the silent shout of the WOW signal, or the hidden hand of Planet 9? Share your thoughts and never stop looking up at the stars with a sense of wonder.